Hello and welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing module number 6 on Unit 3. That is GPS, Global Positioning System. GPS is actually Navstar GPS, that is Navigational Satellite Timing and Ranging Global Positioning System. It's a space-based satellite navigation system which provides information regarding location and time, and it is developed and maintained by USA, and it is open access. Anyone with the GPS receiver will be able to access the information, and it basically consists of 30 plus GPS satellites in medium Earth orbit, and in order to gain information, at least 24 satellites which are working in harmony should be available, and this is called a satellite constellation. And many uses are possible with GPS. Some are navigation, map making, surveying and meteorology. The GPS scheme actually has 3 segments: space segment, control segment and user segment. Space segment is nothing but the satellite section where GPS satellites are flying in circular orbits, and they are powered by solar cell, and their antenna point towards the Earth, and orbits are so designed that at least 6 satellites are always kept within line of sight from any location on the planet. Next comes your control segment. Control segment has 3 entities: master control station, monitor station and ground antenna. The master control station is located at Falcon Air Force in Colorado Springs, and it is responsible for overall management of the remote monitoring and transmission sites, and its basic use is to reposition satellites to maintain an optimal GPS constellation. Apart from this master control station, there are 5 monitor stations located in all these places, and their work is to check the altitude, position, satellite and overall health of the orbiting satellites, and this ensures the GPS satellites orbits and clocks remain within acceptable limits, and a station is capable of tracking 11 satellites at a time, and checkup is to be done by all these places twice a day by each. And in addition to this, you are also having ground antennas, and the basic function of these ground antennas is to monitor and track the satellites from horizon to horizon, and they are capable of transmitting correction information, command and control purpose to the individual satellites. And finally, user segment. It is present in our individual cars, GPS receivers, or in our mobile phones. We are having GPS receivers, and these GPS receivers are composed of an antenna. The antenna is tuned to the frequency transmitted by the satellites and processes a stable clock, which is nothing but a crystal oscillator. Additionally, we will also have a display for showing the location and speed information, and a receiver usually has between 12 to 20 channels. This is signifying how many satellites it can monitor simultaneously. So this is your pictorial representation of the entire GPS system, starting with your space segment, that is the satellite segment, and then you are having monitoring stations that are located on Earth, and finally this is the GPS receiver, that is your user segment. Now, next comes your working principle. How actually the signal is located, or how actually the target is being located. It is done by a geometric principle. So the basic information that is to be determined is the distance between these GPS satellites and the receiver. Then the first thing that is to be determined is the positional information of all the GPS satellites that is actually stored in an almanac. Now the next thing that is to be determined is what is the distance between receiver's position and the GPS satellites. So to get this distance, the first thing that is to be done is you have to transmit a radio signal between these two items, that is the GPS satellite and the GPS receiver. Now there is a formula where the distance is calculated. We are to take the product between the speed at which the radio waves travel and the time it takes for the radio signal to travel from the satellite to the receiver. Take the product, it will give you the distance. And the distance is accurately determined by the principle that is called as trilateration. So the distance measurements from two satellites, as you can see in the picture, two satellites are involved. From two satellites the information is gained. Then the intersection between these two spheres, the location is given actually as a circle. So third measurement is to be done in addition to this. Now there are three satellites that are involved, and now the position is made accurate to 2 points. And a fourth measurement now, which makes use of at least 4 satellites, and now the true location of the target is achieved as a single point. So this accuracy, if you want to gain, means at least, as you can see from the picture, minimum 4 satellites ought to be involved and 4 measurements ought to be done. And the worst case accuracy is 7.8 meters and 95% confidence level. The time accuracy is about 14 nanoseconds. And in case if you want to improve the accuracy further, then augmentation systems are to be involved, and this will enable real-time positioning within a few centimeters, and these are different GPS frequencies and the function for which it is being used. Now, how the GPS system works. Okay. First, the device, that is a GPS receiver, should be installed within the vehicle, and the device will be located by the satellite using GPS, and the GPS value will be sent to the server via general packet radio services, and the server will be storing the data for 365 days, 1 year, and whenever you want to require the information, you ought to just log in on. Now, GPS is actually was actually developed and maintained by USA. Now, from Indian perspective, what are the things that are actually in development for you having this user requirement satisfaction regarding position, navigation and timing services? ISRO and Airport Authority of India have established Gagan system. Gagan is nothing but GPS aided geo-augmented navigation system, and ISRO is also establishing a regional satellite navigation system called Indian Regional Navigation Satellite System. The reason why this GPS we are discussing is it is part and parcel of ITS, that is Intelligent Transport System, and it enables automatical vehicle location and in-vehicle navigation system, and this is also part and parcel of Geographic Information System, and this can display geographic information with systems that can automatically transmit data to display screens or computers. That is the new dimension in surface transportation. And using GPS technology, you can help track and forecast the movement of freight, and time-definite delivery is possible. Time-definite delivery means the trucking companies will be able to track the trucks to guarantee delivery and pick up at the time promised. And this GPS can be installed in a smart mobile device from which you can locate your vehicles, and it can also help drivers to plan assignments and manage costs. And important 3 fields of ITS in which the GPS can be applied is automatic vehicle location, general fleet operation, and dynamic route guidance. What are the benefits of GPS? higher levels of safety and mobility for all the surface transportation system users, and accurate position determination, better location information with e-maps, and this will give you passenger information. It can also provide in-vehicle navigation system both for private and commercial users, and it is also used for effective monitoring, schedule adherence, and it also makes the transit system more responsive and increased efficiencies and reduced costs in surveying roads. The main limitation of GPS is signal loss. In order to get a signal, at least between the GPS antenna and the 4 or more satellites, there should be a clear line of sight. Otherwise, it will be giving out inaccurate data. And another problem is GPS signal may bounce off nearby objects, causing multi-path interference. With this, we will close the session.